So today we're going over 7.05, which is where you're solving equations with variables on both sides, and then 7.06, which is working with rational coefficients. So let's go ahead and begin. Variables on both sides. Your goal when you see a problem like this is to isolate the variable on one side of the equal sign. You can't solve an equation when you have variables on both sides of the equal sign. So to undo operations on that side of the equal sign, you're going to use inverse operations, same as solving one-sided equations. And then you're going to perform the order of operations in reverse after you have isolated your variable onto one side. Keep in mind, you have to keep the equation balanced by doing the same thing for both sides. So here's an example. Now we have 5x minus 8 equals 2x plus 7. The easiest thing to do is to move the smaller coefficient to the larger one. And technically, you could go either way. You could move the 5x over to the right-hand side, but then you're introducing more negative numbers into your problem, and that's typically, it's easier to work with positive numbers, but I've decided in this example I'm going to move the 2x. Now the way I move the 2x, because it's positive, I'm going to do the inverse operation, and that is to subtract. So I subtract 2x from each side. What that does is, let me turn on my pen real quick. That cancels out the 2x that's on this side of the equation, and it moves it to the other side. So what I'm going to do now is rewrite my equation. Now when I'm working with equations, I find it best to always do one step at a time, show that step underneath of my existing equation, and then regroup my equation together and start over by analyzing what has to happen next. So after I have subtracted 2x from each side, I rewrite my total equation. I have 3x minus 8 equals 7. Now this should look familiar. This is your standard two-step equation. You have to get the variable by itself. And because you just moved the variable to the left side, you have to take that constant, that negative 8, and put it on the right side of the equation. You do that by asking yourself what operation is happening to that 8. Right now it's subtraction, so we're going to do the opposite. We're going to add 8 to each side. Adding 8 to negative 8 will cancel it out of this side, and adding 8 to 7 will give us 15. So again, showing my work, then rewriting my equation, I have 3x equals 15. My final step is to finally, once and for all, get that x variable by itself. I see that 3 is being multiplied by x, so I'm going to do the inverse, and that is to divide by 3 on each side. 3 divided by 3 is 1, so that cancels out our coefficient over there. 15 divided by 3 is 5. So I have a final answer of x equals 5. Now, a common mistake is to try to divide or multiply in order to move a variable. This will only split up the coefficient and the variable. It doesn't actually move it. Remember, you can only move a variable from side to side if it is being added or subtracted. It's your best way. So here we have an example whose work is correct. So let's look at the problem. Jonah has 4x plus 2 equals 2x minus 4. What he did, it looks like he subtracted 2 from each side, and that canceled out. He was left with 4x. Over here, he was left with negative 6. One step down, it looks like he subtracted 2x from each side, and that cancels out this 2x. And puts it over here, 2x equals negative 6. Then he divided each side by 2 so that the variable has to be by itself. And he got x equals negative 3. That is correct. That is the right way to do it. Now, even though in our last example we started off by moving the variable, you don't have to technically move the variable first. You can move the constant first. It's just my preference to move the variable first, since I know that that has to be done eventually. And I like to get that done and out of the way first. But honestly, as long as you're not trying to divide or multiply until every like term has been collected, it doesn't matter if you move the constant or the variable first. Now looking at Sarah's work, she subtracted 2 from each side, which is fine. She ended up with 4x equals 2x minus 6, which is fine. But then she tried to divide by 2 because of this coefficient on the variable, and she divided by 2 on each term. And then what she did was she took this x and she just got rid of the x. Even though she divided by 2, she didn't divide by 2x. So that is incorrect because you can't just eliminate a variable by dividing away its coefficient. That doesn't make the variable go anywhere. She needed to move the variable to the other side first. Remember, you cannot solve an equation until all of your like variables have been collected into one term. That's the most important thing you have to do. All right, so we're going to practice this. We have to work through order of operations backwards first, but that does not include doing parentheses and the distributive property. Anytime you see a problem like this that has that with a number outside of a parenthesis and terms on the inside, that's going to be your number one thing you have to solve before you work on inverse operations. You have to distribute that 3. So I'm going to rewrite my equation after using that distributive property, starting with 7x, and then we do 3 times x. We keep that positive sign because they're both positive. We get 3x, and then we do positive 3 times positive 1. We get positive 3, and then we get equals 10x plus 3. Now, what we're going to do is combine our like terms. 7x and 3x equals 10x. Bring down the rest of our equation. We solve one step at a time and rewrite our equation. Now, looking at this, 10x plus 3 equals 10x plus 3. This is an important thing. This has an infinite solution. Anytime you get an equation that is equal on both sides, it doesn't matter what variable or what value you plug into your variable, it's going to always work out. Some equations are like this. They are called infinite solutions. And anytime you notice that your equation is equal on both sides, you can just instantly say, oh, that is an infinite solution. In this example, I solved it all the way down to x equals x, and you can do that too. But just like in my first step, I saw that we got 10x plus 3 equals 10x plus 3. As soon as I noticed it was equal on both sides, I knew right away it was an infinite solution, and you don't have to solve any further. So now we have another example. We're going to distribute 2x because this 2 gets multiplied by that x. Then we're going to multiply the 2 by the negative 3, and we get negative 6. After distributing, I'm going to bring down the rest of my equation so that I can work with it. I solve one step at a time and then rewrite everything. Think of an upside down triangle. In the beginning of your equation, it's going to be longer, and then every step you solve, it gets smaller and smaller. To the end, you have just the solution, and it should look like an upside down triangle. All right, so my next step here is to combine all of my like terms. I'm going to start with 2x and 5x, and we get 7x minus 6 equals 4x minus 15. Now I'm going to move my variables together. I'm going to work with the positive 4x. I'm going to remove that by just subtracting it from each side. When I do that, it eliminates it from this side, and over here I'm left with 3x minus 6 equals negative 15. Now I'm going to move my negative 6 over so that I can have my variable by itself. I'm going to do that by adding 6 to each side, and I'm left with 3x because this gets out of my way. Was negative 9. My last step, I have to isolate the variable completely. 3 and x are being multiplied, so to get x by itself, I'm going to divide by 3 on each side. It's really important to divide by 3 on each side to make sure that your equation stays balanced. Whatever you do to one side of the equation, you have to do to the other. This cancels out, and I get x equals negative 3. And then that is my solution. And here it is, all nice and neat. Any questions so far? Okay. So, equations with rational coefficients, meaning fractions. Here I have a fraction of the coefficient, a variable, and then equals 4. Now some students try to convert every fraction to a decimal because they aren't sure how to handle fractions. Do not use this strategy. You need to be able to work with fractions. Fractions are a very important part of solving equations. You'll have fractions in equations in higher math way more than you'll ever have decimals. And another problem with that is when you convert some decimals, they turn into repeating decimals, and those become really, really difficult to work with. Fractions are always easier to work with in algebra, so learn how to work with the fractions so you can avoid causing problems later. To solve equations with fractions, you need to know how to multiply by the reciprocal. Think of somebody doing a cartwheel. That's like what a reciprocal is. If the fraction was doing a cartwheel, it'd be turned upside down. So the reciprocal for 4/5 is 5/4. It's a fraction that has switched places. The numerator becomes the denominator becomes the numerator. Doing this allows you to get rid of your fraction coefficient so you get your variable by itself. So back to our example, to get a fraction coefficient away from its variable, you multiply by the reciprocal. And remember, you have to multiply each side by the reciprocal. So multiply by 5/4 on each side. This cancels out. And the reason it cancels out is because 4 times 5 is 9, and 5 times 4 is 9. 9 over 9 is equal to 1, and 1x is equal to just x. So that's why we multiply by the reciprocal. Now, working on this side of our equation, 4 as a whole number can be written as a fraction by putting it over 1. All whole numbers have a little invisible denominator of 1 anytime you need them to work with a fraction. So we're multiplying this by 5/4. When you multiply fractions, remember you multiply the numerators, then you multiply the denominators. You do not have to convert them to have the same denominators the way you have to do that with addition and subtraction of fractions. Multiplying fractions is super easy. You just multiply the top numbers, and that's 20. And then you multiply the bottom numbers, and that's 4. Finally, you convert this improper fraction into a proper one by dividing your denominator into your numerator. 4 goes into 20 5 times, so that is your final answer. Now, if there's ever a remainder, you would take that remainder and place it over your original denominator. Let's pretend that this said 22. You would take 4 into 22. It goes 5 times. It has a remainder of 2. That would be your numerator. Your denominator is your original denominator. But we didn't have one. We had a nice, even 20 over 4, which gave us our solution of 5. Next example, negative 6/5 r equals 12. Step 1, our reciprocal is negative 5/6. Keep in mind, anytime you have a negative fraction, your reciprocal is also negative. The reason for this is because you want your variable to not have that negative sign. It'll be transferred to your constant on the other side. Your reciprocal has to be negative if your fraction is also negative. So we're going to multiply each side by negative 5/6. This cancels out our coefficient and we're left with just r. And then 12 times negative 5 is negative 60. 1 times 6 is positive 6. So our fraction is negative 60 over 6. We divide 6 into negative 60 and we get an answer of negative 10. So our answer here, r equals negative 10. All right, do you have any questions about 7.06 or 7.05? Okay, very good. I'm glad that that was helpful. I hope it helped to explain it a little bit more. As you're working through your problems, if you have any questions at all, please send me a text or give me a call. I'll be happy to help you. With fractions and two-step, three-step equations, the more you do, the better you're going to get at it. It's just one of those things you have to practice a lot. And the more you do it, the more it'll become second nature and you'll just be able to fly right through them. But it does take a lot of practice. So if you need any help or if you'd like extra practice, let me know. I'll be more than happy to go over that with you.